guys, welcome back to my YouTube channel. Today we are going to solve day 11 problem on LeetCode. If you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Okay, so now without any delay, let's get started with today's problem. So this is a hard level problem related to cherry pickup. Okay, and in this problem you are given a rows into columns matrix grid, and it is representing a field of cherries where grid I of j represents the number of cherries that you can collect from the ij cell, and you have two robots that can collect cherries for you. So right now these two are the robots. They seems to be in sad mood, so once they collect all the cherries then they will be happy. Okay, so we have given two robots that can collect cherries for you, and robot 1 is located at the top left corner, that is this 0 by 0 cell, and the robot 2 is located at the top right corner, that is this cell. So what is the length of this column? So length of this column, let's say n, then n minus 1. It is located at this n minus 1. So let's say this cols is nothing but the length of our column. Okay, so cols minus 1. So robot 2 is located at the top right corner, and we have to return the maximum number of cherries collection using both robots by following the rules below. So from a cell ij, robot can move either I plus 1, j minus 1. So I plus 1, that is this, and j minus 1, that is this one. Okay, so let's understand. Let me copy this example and let's understand how they are moving. Okay, so let's copy this, paste it here. Okay, so this is example here. So here this robot is here. So let's understand how many cases are possible here. So when my robot 1 moves at this place, okay, this index left side, so this robot 2 can move to this place. Okay, it can move to this place, or it can move to this place. Okay, so these are the scenarios. When my robot 1 moves to left, then a robot 2 has three ways. It can either move to this left, it can move to this center position, or it can move to right position. But here you see, for all these cases, all these three cases, this one, robot 1 is less than 0. So this is my column. Okay, so my columns start from this 0 index. This is 1, this is 2, and these are rows 0, 1, 2, 3. Okay, so right now when robot 0 at this particular cell it moves to the left, then in that case there is no position here, so it is minus 1. So we don't need to consider these cases. We don't need to consider the cases when the new column that it is moving. Okay, whenever the new column, so let's say whenever the new column that robot is moving is always should be greater than or equal to 0. Okay, new column wherever my robot is moving, it should always be greater than equal to 0, and the new column, let's say I'm saying that C1. Okay, so C1 is for our robot 1. Okay, new of C1, it should be greater than equal to 0, and new of C1 should be less than equal to what? It should be less than equal to the length of my cols. It should be less than cols, the length. Okay, so it should always be till here only. Okay, till here only, because these are the only possible test cases. These are the only possible cases. If it is moving beyond that or this after this, then in that case we have to ignore it. Okay, so that is why I am writing like this. If new one C1 is greater than equal to 0, and new of C1 should be less than cols, and one more condition, and for our robot 2, new of C2, it should also always be greater than equal to 0, same. Okay, and new of C2 should less than cols. So these are the possible cases. We have to check only for these particular cases, these specific cases. So here what happens, for the first case my robot 1 is at -1, and after that robot 2 can move to this index 1. Okay, so let's say this is the row 1, this is a row 1. Okay, so my robot is at row 1. So here one more thing, every time these two robots are moving at the same time to the next row. So whenever this R is going to be same for both the robots, because both the robots are moving at the same time to the next row. Okay, but there is going to be difference between the C1 and C2. C1 is for column 1, that is for this robot 1, and C2 is for column 2, that is for robot 2. So initially, for in case of row 1, so these are the cases 1, and this is a row, this is nothing but a row, this is C1 for column 1, and here I am going to write for the C2. Okay, so C2 is at C2 can move to 1 index. So this is one case for row 1. C1 is -1, that is this, and C2 can move to this place. F this 5 is available 1, or C1 is fixed right now, or C2 I can take at this index 2 index. Okay, I can take this value, or I can take this value 1 -1, or C2 is at the right, that is this index 3. But here see, this condition is not right now, because our new C1 should always be greater than equal to 0. So all these scenarios are not possible. But however, there are 3 possibilities. Here I am just saying that we have 3 possibilities, but we don't need to consider these possibilities because this condition is not satisfied. I hope that you guys are able to understand this one. So now let's calculate total possibilities. So these are the 3 possibilities, and after that what happens, my robot 1 moves to this place. My robot 1 moves to this place. So row is same right now, row is same right now. But what happens, it happens that this robot 1, it decides to go to the next column, just down. Okay, no left or not right, just middle one. Okay, so that means it moves to this column 0 in the next row 0. Okay, now when it moves to this 0, so how many possibilities robot 2 has now? So it has again 3 possibilities. It can move to this 5, okay, that is index 1. It can move to this side, that is index 2, or it can move to the right, that is index 3. But here see, these 3, what is the length of coals? Coals length is 3. Coals length is 3 na? Coals length is 3. Okay, so here it should be less than coal's length na? Here condition says that it should not go outside the length of my column. Okay, so this scenario is not possible. These two scenarios are possible. Okay, so here there are total 3 possibilities in which we know that only these 2 are possible. Okay, so right now total how many possibilities? 3 plus 3, 6. Okay, now there is one more case. Now let's say that this robot 0 decides to move to this index. Okay, it decides to move to this index, that is row is same, row is again same. We are at this row, we are talking about this row only. So now my robot this robot 1 decides to let's move to index 1. Okay, let us go to right. So when it goes to right, so let me write every time. So 1 1 1. So here one more thing. Now what are the possibilities for robot 2? It can move to left again, it can move to right, and again move to center and right. So it can move to 1, 2 and 3. Okay, so now this case is also not possible, 1 1 3, because coal's length should be less than 3. New C2 should be less than 3. And is this possible? 1 1 2. Yes, 1 1 2 is possible. This is possible. This is also possible. 1 1 1. These 2 cases are possible. So in total we have total 9 possibilities. 3 here, total 9 possibilities. Okay, so these are all the possibilities. These are all the possibilities in which we have checked for this particular scenario. We are going to check for this particular scenario because these are only possible things, but these are all the possibilities because robot can move to the left, it can move to the again center, it can move to the right. These are the total 9 cases. Okay, so in total we have 9 cases. So here, now let's understand one more thing. So this is robot 1, robot 2. So here both are located at this index. Okay, so here what is the total sum for this particular row? So total sum is 4 here. Okay, total sum is 4 here. Now let's say my robot 1 decides to move to this index, this column, and robot 2 decides to move to this column. Okay, so now in this case this is a number of cherries in a particular row, cherries. Okay, and here again, when my robot 1 decides to move here and robot 2 decides to move here, then how many total cherries right now? So in total for this particular row, total are 7. Okay, total are 7. Now let's say this robot 1 decides to move here and robot 2 decides to move here as well. Okay, both decides to move here. So in this case, how many total cherries? Total cherries 1 only, because what is going to happen if my robot 1 collects this cherry, then robot 2 cannot pick this one. Okay, so only one here it is mentioned. Okay, when any robot passes through a cell, it picks up all the cherries and cell become an empty cell. Okay, so it can't collect this one. Then after that, let's say both moves to this column. Then again we have total possibilities as total cherries that we are going to collect as 2. Okay, now same way here, after that we are again going to check for this left, this right, or this center, or this right for C1. For C2 also we are going to check the same things. Okay, so these are the multiple possibilities, but we need to ignore these things. Okay, we just need to find what are the total possibilities that we have calculated, that this is one possibility. Then again we are going to call our DFS, depth first search method. Again we are going to call this method and it is going to search for the next values. Okay, so once my robot moves to here, robot 1 moves to here and robot 2 moves here, robot 2 moves here, then this value is fixed. Let's say at this I get the value as 4. Now I am going to again use the DFS method. I am again going to use a recursion, and here in this step I am again going to calculate the possibilities. Like for this robot 1, it moves to this place, and for 5 how many possibilities are there? Total 3 possibilities. Then robot 2 moves to this place, then what are the possibilities for 5? Total 3. Then robot 2 moves to this place, then what are the possibilities for 5? Total 3 again. So this is how we are going to approach this problem. So here let's say for this particular example, what's happening? So for this particular example here, what happens? Robot 1 moves to this place, okay, and the robot 2 moves to this place. Okay, so initially what is the value that I get here? That is 4. Okay, because both are at different columns, so total cherries that I have collected in the first row is 4. Then after that my robot 1 reaches here, and then robot 1 has again 3 possibilities. Okay, robot 1 has again 3 possibilities, whether it can move here, 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 or robot 2 has 3 possibilities here, here, here. Okay, total 3 possibilities. So let's say my robot moves to this index, this place, and the robot 2 moves to this place. Okay, so now till here what are the total cherries that I have collected? Both are different columns, so total cherries I have collected as 7. Okay, now again my robot has 3 possibilities. It can move to this place, or this place. It can move to this place, or this place. Okay, but here let's say my robot 1 moves to this place and my robot 2 moves to this place. Then what is the total sum here for this particular row that we get? We get 10. Okay, now after that again we are going to check how many places our robot can move. So our robot can move to this place, this place, this place, or this place, this place, this place. But here we see that we have crossed the rows. There is no row after this. So rows reach to the length of rows. Okay, what is the total length of row? We have reached there. So in that case we have to just return. So here at this particular step we are going to get the sum. So what is the sum here? 3. So, okay, So now after that we are just going to add everything. What is the total sum that we get? Return 13, 20, 24. So 24 is going to be the output, okay, for this question. So now I am going to write the code for this problem. Okay, so with code you will get more clear picture on how we are going to solve this using recursion. So it is a very simple problem. It is much easy than this cherry pickup one problem. It is much easy than pickup one problem. So now without any delay, let's write the code of this problem. So here rows and columns are given to us. Okay, so let me define the rows as, let me calculate the length of rows. So to get the rows length, can I write it like this, grid dot length. Okay, so this will give me the rows length. And to calculate the length of columns, okay, can I write like this, grid first row, okay, and the length of that particular, so it will give the length as whole of the columns. Okay, so this is how I am going to get the rows and columns length. Okay, now after that I am going to create a three-dimensional array, integer to integer. It is going to be three-dimensional, and let's name it memo, and here let's initialize it with new integer. So this is integer, not int. So by default the value stored here is false. Okay, this is not int, this is integer. Okay, new integer, and here I am pass. But what are the values that are keeps on changing? So once our robot moves to the next row, so both are moving at the same time to the next row. So let's give single row. Okay, single rows. Okay, now this robot is present at column 1, okay, and this robot 2 is present at the columns as cols minus 1. Okay, this is 0 and this is cols minus 1. So we are passing but we are passing just cols only, na? So can I write two times? One is for robot 1 and one is cols for the robot 2. So okay, so here I am writing it two times. Now after that, in this function we have to just return the math.max. Okay, so here why I am using math.max. So here I am considering that in case if there are 0 only, if there is no element that we find, then we have to just return 0. Okay, no negative integer, we have to go return just 0 if we didn't find any value or any cherry. Okay, and here inside this I am going to call the method. So in this DFS method, now listen carefully. In this DFS method, first thing that I am passing is grid. Then in Memoization, I am going to store the values. Okay, so that I don't have to repeat the steps. And then initially my robots are at 0 index, right? And calls for first robot is 0. And what is the calls for robot 2? It is nothing but calls minus n. Calls minus 1, sorry, calls minus 1, because this is the length. Okay, calls minus 1. So I have passed this. So now this is done. Now after this we have to write our DFS method. Okay, so here why I am using Memoization. So here let's see. So here from here, when my both robots are here, so they are going to check for this one. Same way, if my robots decides to move here, any robots, then it has again the three possibilities. It can move either this way, or this way. So we have already checked at this particular index. We have already checked at this particular cell when our both robots are this place. Now, when our both robots are at this index, then we have checked for this particular cell. But once my robots reaches this, then it has to check for this one. So instead of checking for this particular cell again, I am going to store that value into the Memoization. Okay, so now let's write our DFS method. So this is very simple. Private static int DFS, and in this DFS I am going to pass what? I am going to pass our grid, and after that I am going to pass our Memoization that we have created, integer. Okay, then memo, and then after that but we are passing one our row 1, we are passing column 1, and we are passing C2. So C2 is for robot 2, C1 is for column 1, robot 1, and R1 is a row. Okay, so now let's write inside that. So here inside that we are going to use these rows and calls. So these are going to be same. Okay, so here we get the rows and calls length. Then after that I am checking if my R1 is equal to rows. Okay, that means that I am checking for this particular place. So in this point of time my R1 is going to become rows na. So in that case I am just going to return 0. Okay, because there is no cherry available, so I'm going to return 0. So this is going to be my first base condition. Then after that I'm going to use the memoization that I have created. So here in memo I am passing R1, C1, and C2. So I am checking, by default the value is false, so I am checking if this is not false, that means that we have already covered already implemented this cell. If by default it is null, it is null. Okay, is not equal to null, then what we are going to do, we are going to check, we are going to return, okay, memo. So here by default it is null. Okay, so I think I have said that it's false true. No, it is not boolean. By default it is null. Okay, so it is integer, not boolean. So in case of int, by default initialized to 0, but in case of integer we can it is going to initialize as a null. This is a multi-dimensional array but of integer type, so that is why by default it is null. If it is of int type, then by default it is of 0. Okay, by default values assigned is 0, but it is integer. Okay, so if it is not null, that means that we have already covered. So in that case we have to just return the value that is stored at this particular R1, C1 and C2. Okay, for this particular row and C1, C2. So this is the value that I am going to return. Okay, now let me write it inside this curly braces. Okay, so now this is done. Now after this we are going to check. Let's check for this particular row. Let's check for this particular row how many cherries we have collected in this first row. How many cherries we have collected in this first row. Okay, see my cursor, this row. So can I write it like this? Int cherries, int cherries is equal to, here this is my array, grid array. Here I passed R1, initially it is 0, right, and C1 is also 0. Robot 1 is present at R1, C1, that is 0 0 plus. Now here I am checking one more thing. If in this case, see here, when I said that both the robots are reached to the same particular cell. Okay, if both the robots reach that same particular cell, then we don't then only one robot can take this cherry and other one has doesn't have any cherries left. So here I am checking if can I write it like this, C1 is not equal to C2. If this is the case, so we are good. If this is the case, then we are good. Then we have to check, then we have to get the value of grid R1 C2, grid R1 C2. Okay, but if this condition is not satisfied, okay, that means that both the robots are at same place, then we have to just add 0. Okay, so here if both the robots are at different places, then I am going to add 3 plus 1. But in case if both the robots are at same place, if both the robots are same place, then I am going to take for the first one. Then after that I am checking the condition, and here I am ignoring this. If this condition is not true, then I am ignoring it. Okay, so this is I hope that you guys are clear with this one. Now after that I am going to get the max cherries. So let's create one variable max cherries, okay, and initialize it with 0. Now I am going to check for the 3 possibilities. So as I have told you that there are total 3 possibilities. This robot 1 can move to this index, and this index, left, right, left, mid, and right. So can I write it like this for this particular robot? For one robot, can I write like this? Int I is starting from -1, that is left index, and I is less than equal to 1. So 0 is mid and 1 is right. When I is at 1, that is means right. And here I am incrementing the I. And after that, same for robot 2, I am writing like this. Int j is starting from -1, j is less than equal to 1, and j plus plus. Okay, now inside this I am creating the new column. What is my new column? So my new column is nothing but new c1. It is going to be what? New c1 is going to be, this robot is present at c1. Okay, c1 plus I. So here in the first case, when I do c1 plus I, then that simply means that I am moving left, because I is -1, c1 is at 0, so 0 plus -1, so that means I am moving this left side. Okay, so now I am moving left side, and new c2 same way. New c2 is equal to, I am moving to this c2 and plus j. So here j is also moving to -1 initially, -1. So here j, so this is the case now. So here first I told you that this -1 is fixed now. For outer loop, -1 is fixed. Now my j is going to move from -1 to 1. So that is this 0, 1, 2, 3 for this one. So initially it is 1. Why it is 1? Because c2 is present at this index, that is 2. 2 plus -1, that is 1. So it moves to this left. Okay, so I hope that you guys are clear. Now here I have to give this condition, this big condition. If my new c1 is greater than equal to 0, and new of c1, it should be less than, but it should be less than my calls. It's so confusing. Calls, and now it is in small caps, right? New c2 should be greater than equal to 0, and it should be less than, new should be here, new c2, okay, should be less than calls. So I am going to check for this condition, huh? So if my new of c1 is greater than equal to 0, new of c1 is less than calls, and then new of c2 should be greater than equal to 0, and then new c2 of less than so. So if this all the conditions are true, in that case I am going to update max carries. I am going to update max carries, CHERRIES, max carries as maximum value. But maximum value, math.max of initial value that by default I have given to this max carries. Okay, so I am passing this value, and now inside that I am again going to use this dfx method. I am going to call this method because I don't know the value. So how it is going to happen? Grid memo, it is going to same. And here for rows, if my robot 1 reaches this position, then after that it is going to search for the next row. So here can I write it like this? Rows plus 1, right? I can write like this, rows plus 1. Rows is r1. In our case I am saying it r1. Okay, so r1 plus 1. So initially my robot is at this index, let's say r1. So after that it is going to search for the next row. So that is why I give r1. And here this 0, this is c1 column. So initially if this is at this column, so can I say it this new c1 only, because my robot is right now present at this one. So I am going to search from here only, because my robots are present at new c2, new c1 and new c2 right now. So I am going to implement again code for this method when my robots are at this index, new c1 and new c2, and this is r1 plus 1. Okay, r1 plus 1. Okay, so I hope that you guys are clear. So if this condition is satisfied, then after that I am moving forward. So I am going to get the max carries, and again I am going to call the method, this method. I am going to search for the next rows, and this is the present location of my robots. Okay, so now this is how it is going to calculate. Then in the end, okay, in the end what we have to do, we have to store the values of memo of R1, C1 and C2. We have to store all these values. We have to store all these values in the, this value is the result of cherries at the previous step and the new cherries that we have get, latest cherries. So max cherries, and in the end we have to just return what, we have to return memo of R1, C1 and C2. Okay, this is what we have to return in the end. Okay, so now let me run our code and see if there are any code issues or any spelling mistakes in our code. So let's see. So our code is running and this is the first mistake that we find. So we didn't use the semicolon in this line number 25. Okay, so let me use the semicolon here, and now let's run it. Okay, so here what's the mistake, grid of R1 C1 plus it is checking, okay, C1 not equal to C2, then grid of, okay, so here second type is equal to boolean. Okay, line number 18. Okay, so now let's see line number 18. Int cherries is equal to grid of R1 C1 plus C1 not equal to C2. Okay, what I'm doing here, this is a complete set now. C1 of C is not equal to C2, then this is implemented, otherwise this 0 is implemented. So here I have to use this. Okay, let me run the code. So both the test cases has been accepted. Now let me submit our code. So in this code we are using recursion and memoization. Okay, so our solution is accepted, and I hope that you guys are able to understand today's problem. If you guys still have any question, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Thank you. Bye bye. Meet you in the next video.